Assalamualaikum warahmatullahi wabarakatuh. Hello, my name is Taqiyya Najla Syarif with student number 2206829950. Today I'm going to presenting my final exam answer for numerical method class. From the previous video, I already explained for the number 1, 2, 3, and 4. And in this video, we're going to move on to the number 5 and the bonus question about Elon Musk. So we're going to question. Okay. This is the question for number 5. We're going to solve this with a framework called Day 5. The first point is intention. We aim to model and analyze the suspension system of an SD trailer traversing rugged terrain using extreme shock and assess whether it can handle the applied impulses without compromising structural integrity. This will involve establishing and solving the initial value problem or IVP for a system, determining maximum and minimum displacement, and providing recommendation based on the result. Next, this is the initial thinking to approach this problem. We have four. The first one is to establish the IVP, which means define the differential equation for the system with impulses modeled by the direct delta function and include the given parameters: mass, spring constant, damping coefficient, impulse force, number of impulses, and time interval between impulses. And next, solve the IVP, which means use Laplace transform to solve the differential equation and verify the solution using mathematics. And then next, analyze displacement, which means determine the maximum and minimum displacement from the solution and discuss the system performance. And last but not least, structural integrity assessment, which means check if the displacement exceeds the shock limit, consider the effect of decreasing the time between impulses, and provide recommendation for traversing rugged terrain. Okay, this is the idealization. We have model assumption and differential equation. In model assumption, we know the mass of the loaded trailer, spring constant, damping coefficient, impulse force, number of impulses, time interval between impulses, and initial condition, trailer initially at rest at equilibrium. In differential equation, the equation for the damped harmonic oscillator with impulses is given by the slide. Okay, the instruction set, the first one is establish the IVP. Define the differential equation for the system with given parameters and initial condition. Step 2 is solve the IVP using Laplace transforms. So the first is establish the initial value problem, the equation governing system with initial condition. We can solve by hand using Laplace transform. And taking the Laplace transform of both sides of the differential equation, and we are going to try simplifying it using partial fraction decomposition and inverse Laplace transform techniques. We can solve for xt. Okay, this is step 3. Analyze displacement, maximum and minimum displacement, which means using the solution xt obtained, find x max and x min by evaluating the solution at relevant points. And next is discuss performance, evaluate how well the shock perform under the modeled condition. For step 4 is structural integrity assessment. The first point is assess for 3 seconds, check if the displacement exceeds 0.2 meters. And the point 2 is assess for 2 seconds, analyze the effect of decreasing the time between impulses. And then the last point is provide guidance. Guidance recommendation based on the analysis for safely traversing rugged terrain. Okay, the conclusion by the instruction set is summarize findings from the solution, displacement analysis, and structural integrity assessment. Provide recommendations for safely traversing rugged terrain with the STT trailer. Okay, this is the bonus question. Describe your comment about Elon Musk's question to AGI with pronunciation she. And the question is what's outside the simulation? Okay, Elon Musk's question, what's outside the simulation, taps into a fascinating and complex philosophical and scientific debate about the nature of our reality. If we assume, for the sake of argument, that we are indeed living in a simulated universe, this question prompts us to consider the following layers of inquiry. Okay, the nature of the simulation. Um, Maybe I can make the become 2 points. The first point is simulation hypothesis, and the second point is reality of the simulators. For the simulation hypothesis, the idea that our universe is an artificial simulation created by an advanced civilization. This hypothesis, popularized by philosopher Nick Bostrom, suggests that future civilizations might run simulations of their ancestors, making it statistically likely that we are in such a simulation. And then for the point two is reality of the simulators. Assuming the simulation hypothesis is true, outside the simulation would be the reality in which the simulators exist. This reality could be vastly different from our own, possibly more technologically advanced and complex. Okay, maybe I can take the conclusion. Elon Musk's question, what's outside the simulation, challenge us to think beyond the boundaries of our current understanding of reality. It intertwines scientific curiosity with deep philosophical inquiry, encouraging us to explore the fundamental nature of existence, the limits of knowledge, and the potential implication of living in a simulated universe. While we may never have definitive answer, the pursuit of such question pushes the boundaries of human thought, of uh, the simulation and understanding. I guess that's all for my final exam videos. Thank you for watching. Wassalamualaikum warahmatullahi wabarakatuh.